Transtec Gotthard, 4 partners for the project of the century. Installing the technology for the longest train tunnel in the world is a pioneering achievement, because the Gotthard Base Tunnel consists of 2 single-track tubes, each of them 57 kilometers long. Which means that every day for 6 whole years the men and machinery need to be transported to their place of work with absolute precision. The work sequences in the single-tube tunnels have to be organized in such a way that different jobs inside a series of successive sections can be carried out simultaneously. The implementation of this colossal project therefore requires perfect interplay between all the companies involved. The companies that form part of the consortium Transtec Gotthard. Since 2008, the experts from Transtec Gotthard have planned construction, monitored implementation, and steered the commissioning processes. The first major step, setting up the infrastructure for this massive building site. On this 70,000 square meter area in Biasca, near the South Portal, one of the support points is being constructed. It will serve as a base for the rail technology installation work. The temporary infrastructure also includes road connections, sections of platforms, and office buildings. The personnel quarters can accommodate up to 250 workers who work in the tunnel on a shift basis. Parts of the provisional buildings need to be specially planned so that they can be moved from the installation site in Biasca to the north portal of the Gotthard Base Tunnel. For instance, a silo has to be transported to the installation site near Erstfeld. This allows the rail technology to be installed in the tunnel from 2 bases, and partly even parallel. Without the high-powered ventilation and cooling during the installation phase, working 2,500 meters below solid rock would be quite impossible in the first place. Over 600 engineers, project development personnel and fitters from Transtec Gotthard work hard to implement the work contract, which fills almost 100 heavy files. The basic framework for all the work is the overall timing schedule. In addition to the provisional buildings, this plan also contains 4 large service packages: power supply 50 Hz and cable systems, construction of the track, traction current 16.7 Hz, and telecommunications and safety systems. Installing the power supply is the task of the Alpic Burkharter Bahntechnik AG. The power supply requirement for the Gotthard Base Tunnel is equivalent to that of a town with 15,000 inhabitants. A total of 3,200 kilometers of copper cable are pulled into the cemented-in cable protection tubes along the shoulder by the team from Arbach, with multifunctional vehicles specially designed for use in the Gotthard. In the cross passages, switchgear distributes the power to the consumers. The different voltages in the feeder networks are brought up to a uniform voltage level outside the tunnel in 3 rail technology buildings. This work is done by coupling transformers, each weighing 2.5 tons. The power for the trains, tunnel ventilators, lighting, signal boxes and communication systems has to flow at all times. If the power supply is ever interrupted, the diesel generators in the so-called no-brake systems spring into action automatically. The installation of the fixed track is the task of the Belfer BT Rail and Alpine joint venture. The men from the long train lay the track on which they're travelling all by themselves. The pulling unit pulls the 120-meter long rail pairs over temporarily installed rollers into the correct position. The automatic welder heats the ends of the rails until they're white hot. A gantry crane places sleeper blocks for the next shift, and then the specialist track construction team takes over. The robot moves slightly further forward for assembly of the next 2 out of a total of roughly 380,000 sleepers in the entire Gotthard Base Tunnel project. These measuring points are used by the construction team to position rails with pinpoint precision. The concrete train, a cement mixing plant on wheels, 500 meters long. This special design produces fresh concrete directly inside the tunnel. The shuttle provides transport to the placement location. Handover is timed down to the minute. This enables the track to be built in an industrial process. At the same time, the highest quality standards are only achieved through manual labor, smoothing of the concrete, for instance. The men lay over 200 meters of track each day. 48 hours later, the new rails are ready for travel. The installation of the overhead contact line in a project of this size requires highly detailed planning. If all the planning documents were spread out, they would cover the area of 3 football pitches. The Balfour Beatty Rail and Kumlau und Matter joint venture has the task of installing the power supply. Over 40,000 drill holes and anchors and around 6,000 supports are installed by the fitters. At the installation site, the components are pre-assembled as far as possible. The result? Fast and efficient assembly inside the tunnel. The forklift transfers suspension pillars to the fitters on the platform of the construction train. High-powered solenoids bear the weight until it has been securely fixed. Each of these pillars weighs 150 kilos. The self-propelled rail trucks have electromechanical drives. This enables the men to reach every work position with pinpoint accuracy and to assemble the cantilevers with insulators from the specially designed lifting platform. For operation at 250 kilometers per hour, the contact wire has to be adjusted precisely to 5 meters 20. Weights ensure that the catenary system is detensioned. The fitters install a total of 1,400 tons of copper in the Gotthard Base Tunnel. So that several trains can use the 57-kilometer-long stretch simultaneously, 4 line feeders supply the contact wire with the necessary power. The installation of the telecommunications system is the task of Alcatel-Lucent. The transmission medium in the Gotthard Base Tunnel is a so-called leaky cable that transmits radio signals. This enables passengers to use mobile phones and internet during the journey. But this is just one small part of the telecommunication system. A network with more than 70,000 data points forms the central communications element, and it has been lab tested. Take operational communications, for instance. The standard phones in the operational buildings are connected via voice over IP. A black box records the conversations. Another example, the tunnel control system. It controls the electromechanical systems such as doors, ventilation and lighting. Any faults are instantly displayed in both the north and south control centers. From here, for instance, the operator can also open the doors of the emergency center. A third example, the tunnel radio system via GSM-R. It transmits data and speech for operation of the train traffic and for rescue measures. The trains that will travel at high speed through the tunnel are monitored and controlled using rail safety systems from Thales Rail Signaling Solutions. In the laboratory in Zurich, the engineers and system designers test this system for safety and reliability in every conceivable situation. Each train is constantly monitored by means of the radio-based train control system ETCS Level 2. ETCS stands for European Train Control System. Level 2 means that the speed the train driver has to travel at is displayed to him in his cab. Transponders locate the train's position, and over 700 axle counters establish whether sections of track are free or not. 4 electronic signal boxes regulate the mixed traffic made up of passenger trains traveling at 250 and goods trains at 160. All in all, 300 trains per day. Transtec Gotthard is a consortium made up of rail technology companies that are leaders in their field. And Transtec Gotthard has a clear objective: the commissioning of the Gotthard Base Tunnel at the end of 2016. A new, fast and efficient rail connection between Northern and Southern Europe in the heart of Switzerland. Transtec Gotthard. 4 partners for the project of the century.